Okay, so this is another way of solving um, a system of equations using, um, this time around we use the inverse. We did it in one of the previous videos, but there's no harm in repeating it under this section as well. Okay, so this is the second method. The first method we used was elimination method. Okay, so we said that this has got a few steps. So the first step is you create a matrix of cofactors. Then the second step is you get the determinant from the matrix of cofactors. Okay, then the third step is you get the adjoint. Okay, the adjoint we get it from a matrix of cofactors. Okay, then 4 we combine determinant, and in fact let's say we get the inverse of the matrix provided by multiplying the determinant, the inverse of the determinant, and the adjoint. Okay, once we get the inverse, we multiply the inverse, and the matrix B to get solutions. Okay, so what is matrix B? Matrix A is the one that we form from this set of numbers and variables, and matrix B is the one we get from here. Okay, all right, so let's do the extraction. Let's create the matrix. The matrix is going to be 1, 2, 2. Okay, then this one will be -1, -1, 2. Remember, we get the coefficient of the variables here. Then we get -1, -1, and 1. These are the coefficients. Then we say that we multiply this by these. Then we get the solutions, the answers this side. Okay, now remember, if we were to multiply these, so x times 1 times x gives me x, -1 times y gives me -y, -1 times z, -1 times z gives me, sorry, this is, yes. This is not -1, this is +1. Okay, so +1 times z, we get plus z. So you can see that we can form this stage from this stage here. Okay, so now let's look at the stages. The first stage, which is cofactors, is a matrix called C. So this one we form it by opening this up, and we say that we have our good friend, the plus, minus, plus, that we cannot do without, like that. All right, so now what do we do here? What we do is we come here, we look at this. Remember how we used to get them? So we use here, and we use that. But then whatever remains here, which is here and there, is what we use to form this set here that will have a plus. So here we're going to form this set, which is -1, 2, and then -1, 1, like that. Right? Then we go to -1 here. Okay, so now we look at this position here, but obviously in conjunction with this sign here. So this position is going to have us have 2, 2, which is here, and then also -1, 1, -1, 1. Then we have this position here. the last one is going to leave us with this, which is 2, 2, and minus 1, 1. Now, I was asked to confirm. Okay, this is supposed to be another line here. I was asked to confirm that, if there was a way in which you can try to check if what you've collected from here is correct. Okay, I think the only way is you can check this and compare with the last one here. Okay, you check these two and see if they're the same. If they're different, then it means that you have missed out something. So let's check the last one here. The last is here, and then we are collecting these two. So already you can use that to prove if what you collected is correct. Then the middle one is actually formed from this element here. Okay, let me color them. This and that then form the middle set. How? This one comes this side and this one comes this side. So you see that this is 2, 2, this is minus 1, 1. Okay, so it came from here, it's there. This one has come from here, that one has come from here. Then these two, the first and the last are the same. So it's only way that you can use to clarify if indeed what you've collected is correct. So let's complete the other ones. Okay, I've gone ahead and completed the rest. Same way like we did at first. So we can check if we are right. So we get the negative sign from here, we put it there, then we repeat these two. By obviously we're at this location here, meaning that this straight one and that are out. So we're just going to get this and that, which is negative 1, 2, and then 1, 1. Like that. So we compare the first and the last, they're same. Then we get this one, put it here, and get that one there. That one has proved. We check the first and the last, they're same here. We check here, it's same. We check here, it's same. But then you have to be careful not to cheat yourself, like form it from these same ones. You have to form it from this and then just cross check at the end, like I've done. All right, so the next step is that we're going to calculate these to form our matrix of cofactors. So our matrix of cofactors, we'll put it here now. Okay, so we're just going to multiply, then subtract. So this is minus 1, minus 2. Okay, minus 1, minus 2. This is minus 1, minus 2. So that one will give us 1. Then we check this one as well. Cross. 1 times 2 is 2. Minus 1, that's plus. Minus 2, that's plus. So that's 4. But then negative, which is minus 4. We check this one. This is 2. That's 4. Minus 2, that gives us 6. Okay, so that gives us 6. So we're going to have a 6 here. Here, a minus 4. Right, so we'll do the same for the rest here. Okay, so we've got our cofactors now. Okay, so those are our cofactors. Now the next step is that we're going to, so the same way we did the first line is the same way I've done the second and third lines. So an example, maybe in the middle here, all you do is you cross multiply. That's 1 minus 2. If I multiply this, minus 2, that's negative 1. There's no sign here. It's positive. Here that's 2, minus 1, minus 2, so that's 4. And then we use a negative, that gives us minus 2. So now we transpose. Transposition is easy. This becomes a row, that becomes a row, that becomes a row in the next one. Or this becomes a column, a column. I like to change rows to columns. That's how I like to think of it. So here I'll do 1 minus 4, 6. You see that was my row. Now it's my column. Then here I go 3 minus 4, minus 1. Okay. Then minus 4. Then I take my last one, 2, 3, 1. So whatever you decide to do at first is what you do for each one of these. You can't change this to a row, then you decide to change, you change this one, say, to a column, then you decide to change this one to something else. You really have to make sure that you're changing, you have consistency. So if I choose to change my columns, it means that this one becomes my first row this side. So 1, 3, 2, 1, 3, 2, 4, 1, 3, 4, 1, 3 with their signs. 6, 4, 1, 6, 4, 1, like that. Okay. Then next we get the determinant. Okay. So this is the adjoint as well. This will be your adjoint. All right. So now we get the determinant. We said that we've already applied these, so we'll just use the first line here in conjunction with this line here. So I'll get my 1, I'll multiply by 1 from here. Okay, then I do plus because now I use my negative already. So I get the coefficient, which is minus 1. Then I multiply with what I found with my cofactor. Not the one from this one which has been transposed, but from the one which is not transposed. Okay, then we get plus 1, the one from here, right? Then we use a cofactor for that position, which is 6. Remember, a cofactor, not one which is transposed. Meaning that I have 1, here I've got plus 4, and then here I've got plus 6. Together, this will give me 11. Okay, so that is my determinant. Okay, then now we get our inverse of the matrix, which will be 1 over 11 times the adjoint. The adjoint, which is 1, 3, 2, minus 4, minus 1, 3, then 6, 4, 1, negative. Okay, now my solutions are going to be x, y, z is equal to 1 over 11. I have my 1, 3, 2, minus 4. Remember, I'm getting my adjoint, minus 1, 3. This is my adjoint, not my cofactors now. Then 6, 4, 1. Remember, this is negative. Like that. Then I multiply this with my B, my matrix B. So you remember how we used to multiply? We said this is 1 times 2. 1 times 2 gives us 2. 3 times minus 6, that's minus 18. So that gives us minus 16. Then 4 times minus 6, this is minus 6. So 16 minus 6, minus 6 minus 16 gives us minus 22. We get our this one. So just to, all right, just to show us here what we did. So I said 1 times 2, okay, 1 times 2, then plus 3, 3 times minus 6, plus 2. Remember, you don't leave out any signs to give you like that. So this is 2 plus, this is minus 18, and then this is minus 6. So remember, this now will give us minus 24 minus 2, that's 22. So we have 22 here, right? Then we do the same for this one, we do the same for that one. Okay, so the middle one, we said it's going to be this and that, which is this element here. And then we have minus 1, minus 6, minus 1, minus 6. And then we have this one and that one, minus 3, 3, minus 3. So it gives us this for a total of minus 11, which is here. We put minus 11 there. Okay, so for this one, again, we do 6 and 2, which is here. Then we do minus 4 and minus 6, which is there. And then we do 1 and 3, which is there. So it will give us 12, 24, and minus 3. Together, we have 36 minus 3, which is 33. So we get 33 here. So to conclude, we'll get x, y, and z. So here now, we're going to multiply a scalar. Remember, we did scalar. So this is our scalar factor. Then we multiply by the elements inside, or the entries. So this is going to be 2. And then this is going to be minus 1. And then that's going to be 3. So therefore, we can say that x is equal to 2, y is equal to minus 1, and z is equal to 3. These are our solutions. So you can get these values and put them in any of these to show that your work is correct. So for example, if I get these and try to, in the first one, that will be 2. So that's 2. Then I get minus 1, that's plus 1. Okay. Then we're going to have, this. Okay, so we dropped a negative here by mistake, because it was supposed to be 2 minus 18 minus 6. That gave us minus 22. Okay, so this one will give us minus. So here now we have negative 2. And then if we put 3 there, okay, so now we're going to put 3 here. Plus 3 is equal to 2. So you see that this is 4. And this is minus 2. And so we get 2 is equal to 2. Okay, so we've proved. Normally this is supposed to, these solutions, you're supposed to use them on all the 3 to show that they are valid for all the 3 equations. Okay, so the only mistake that we made here was that we dropped a negative here, because we're trying to do our mental arithmetic here. Like I've always said, it's better to write down like this, so you don't drop any negatives or any numbers. But essentially, this is what all there is to solving using the matrix method. So you see, you do cofactors. We did cofactors here, which ended up at here. Okay, so this was 1. Then we went and found our determinant. Our determinant was here. Okay, we went on and found the adjoint. The adjoint was here, which was number 3. Then we went on and found the inverse. Our inverse was here, which is number 4, right? Then we went on and looked for our solutions by multiplying the determinant or the inverse and solution set B. Our solution, our matrix B rather, which is here, same as there. So we found these solutions, and then our determinant became a scalar that we multiplied with the contents or the elements of the product of the adjoint and matrix B. Then we got our solutions here. Then the final stage was we tested the solution against one of the equations, and that proved to be true. So all in all, this was our work. All the best and take care.